All right, guys, today we're gonna be reviewing your study guide number 2, and we're gonna solve problems 1 through 10. Okay, so this is chapters 4 through 6, problems 1 through 10. That's what you're gonna try to solve on the first day of exam 2. In order to solve problem 1, you need to read the page that I wrote for you, okay, in your red study guide. This page right here that talks about relations and functions, you need to read through that in order to be able to evaluate problem number 1 and problem number 2. Yeah, problem number 1 and number 2, which are asking you questions about relations and functions. So the first thing you need to remember is that a relation is any set of ordered pairs. Ordered pair is an x value and a y value. Okay, so a relation is any set of ordered pairs. That's the first thing you need to remember. The second thing you need to remember is that the domain of a relation is made up of its x coordinates, okay, the first element in each ordered pair. And the range of a relation is the set of y coordinates, or the second element of the ordered pairs. A relation is also a function if every x value is paired with one and only one y value. So a relation can't have an x value that has more than one y value, okay, 2 or more y values. If it does, it is not a function. It could be a relation, it can be a set of ordered pairs, but it can't be a function. You can test that with a vertical line test, where if you were to graph those ordered pairs and you pass a vertical line through that line, through those points, you would never have 2 points touching at the same time. If you do, it fails and it is not a relation. Okay, so for number 1, the first question that you have is to choose a description of the letter corresponding to the correct description of each set. Okay, so for set number 1, we've got negative 2.63 and 4.93. Okay, negative 2.63 and 4.93. And we're supposed to answer, is it A, both a function and a relation? Is it B, a relation that is not a function? Or is it C, neither a relation nor a function? This one has one x value here and to one y value. This one has a different x value and a single y value. Now they have the same y value, but each x has only one y. If I were to plot this, guys, to have 2.6, like say I wanted to put the domain here, I had 2.6 and 4.9, and then I had the range over here. So this is the domain, which are your x values, and this is the range, which are your y values, and there's only one, right? One y value. Each x has one y. It's the same y, but that's okay. Each x has only one y. So the answer to this is the letter A, is both. Okay, a relation and a function. Now, the next set of ordered pairs, okay, so this was set number 1. The next set of ordered pairs, set 2, your pairs are 2, 3, 3, 4, and 3, 5. You can see here, okay, so if we're paying attention, if I were to make a diagram of these, okay, and I were to say, all right, here's my domain, my x values, that's these 3. So I have 2 and I have 3 twice. And if I put my range values here, my y values, I've got 3, 4, and 5. When I pair these, 2, this x right here pairs with this y. 2 goes to 3. This x, 3, pairs with 4. And this x, the same 3, pairs with 5. Now I have a problem. I do have a relation It is a relation, yes, because it's a set of ordered pairs, but it's not a function because my x value 3, this value in my domain, has 2 y's, and that's not, that doesn't pass the test, okay, for a function. So your answer then is letter B. It's a relation that's not a function. Okay, you have one more set. And this set is going to look crazy. This set has 3 values in each group, okay? Oops, and 0. 3 values. This is not a set of ordered pairs at all, right? It has 3 values. It needs to have 2, an x and a y, and it's got 3. So whatever is going on here, it's not a relation, and it's not a function. We can't even test it for a function because it doesn't have an x and a y value. So it fails both of those, which means it's letter C, neither a relation nor a function. Okay, that's what you need to know to answer problem number 1 on this test. Now, to answer problem number 2, which of the following relations are functions? You've got as options A, and you need to look at your study guide in this. You don't want me drawing all of these again. So I'm just going to draw the letters A, B, C, and D. For letter A, you're looking at a map. Okay, you're looking at a map, and you can see for letter A that 0 is paired to 400, 1 is paired to 100, and 2, your domain value, has 2 y values. Okay, the question is, which of the following relations are functions? This one is not. That one's not a function because 2 in your domain has 2 y values. You have an x value that has 2 y values, so that one's out. For letter B, if you were to pass a line, okay, through that graph, you've got a coordinate plane and you've got 2 lines on it. And if you were to pass your pencil through that coordinate plane, there would be a couple of points where your pencil touches 2 points at one time. Okay, that means that one or more of those x values has 2 or more y values. So this one's out. That one's not a function. All right? When we get to letter C and you've got a cubed function, right? You've got that curve. If you were to pass your pencil through that line, which you can do, right? You've got your study guide out. It never touches more than 1 point at one time. So this one is a yes. This one is. It passes that vertical line test. When you look at letter D, you have 4 domain values, 10, 20, 30, and 40, and each one has a single y value, a single value in the range, right? 10 pairs with 5, 20 pairs with 15, 30 pairs with 5, 40 pairs with 10. You don't have any domain values that are going to the same range value, okay? You have range values, the y values that share an x, but you don't have any x's that share a y, all right? Does that make sense? I might have said that backwards, but I think you understand what I'm saying. Okay, so this one passes the test. I will show you on my study guide so you can kind of see this again. So for letter A, this is not a function, okay, because the domain value 2, this one right here, has 2 y's, so it's out. For letter B, this is what we're talking about. You pass your pencil through here, it's gonna hit 2 points at once, here and here. So this is out. This is not a function because these x values have 2 y values. Okay, so it's not a function. This one passes. I don't touch any double y values when I pass my pencil through. It only touches 1 point at a time at any given time. And then letter D, each one of these has a single y value. Each x has one and only one y value, so this one passes. So when you're choosing your correct responses, your answers are C and D. Those are relations that are also functions. All right. So my answers here are C and D. Okay, let's move on to number 3. In fact, I'm going to do that on this piece of paper. I know it looks like I don't have a lot of room, but I don't need a lot of room. I have 5 scatter plots. Okay, 5 scatter plots that I need to look at on page 252 of my book. So you guys need to turn in your book to 252. We've got these scatter plots. In fact, I'll just show it to you, okay? Okay, here we go. Scatter plots. 1, 2, 3, 4, and 5. A scatter plot is a plot of points where you are evaluating how those points are related to one another. So please read page 250 of your textbook to remind yourself of what that means. Basically, when you have points that are moving down, descending from left to right, that's called a negative correlation. If you have points that are ascending from left to right, just like the slope of a line, that's called a positive correlation. So just like this would be a negative slope and a positive slope, this is a negative correlation, this is a positive correlation. The closer those points are together, okay, in a strong line, the stronger the correlation is. The more widespread they are, the weaker the correlation is. So when we're looking at number 1, 2, 3, 4, and 5, and our choices here, we're going to assign one letter for each of these scatter plots. We need to choose which one is a strong positive, which one is a weak positive, which one has little or no correlation, which one's a weak negative, and which one is a strong negative correlation. You can see the answers here, all right? So for number 1, and you can fill these in on your study guide, for number 1, the correct letter is E. This is a strong negative correlation. So the more we move on the x-axis, the more we fall on the y-axis. That's a strong negative correlation. This one here is showing a weak positive. Yes, it's generally moving in a positive direction from left to right, moving up from left to right, but there's a lot of space between these points, so it's a positive correlation, but it's a weak one. Number 3, we have little or no correlation here, so we can't really detect if this is moving up or down from left to right, positive or negative, and all of our points are pretty well spaced out. So we're going to call this one a little or no correlation. These guys are in more of a group here, okay, but not nearly as strong as this. So this is a negative correlation, but it's a weak negative correlation, and that's letter D. Same thing here. I don't have a straight line, but I do have a general trend of points that are increasing on the y-axis as we increase on the x-axis, and so we're going to call this a weak positive, we're going to call this one a strong positive correlation because they're much closer together than this one's. This one's weaker, this one's stronger, so that's our best choice for number 5. So here are the answers if you're putting them in your study guide. Number 1 is E, number 2 is B, number 3 is C, number 4 is D, and number 5 is A. All right. Those take time to explain, but they probably won't take a lot of time for you to answer on your study guide. So let's go ahead now and move on to number 4. Again, we're going to try to get all the way to number 10. Okay, number 4, state the slope and the y-intercept of this equation. 1/2 y equals x minus 3. So they're asking me for the slope and for the y-intercept. So I want this in slope-intercept form, which is y equals mx plus b. It's not in that form. I need to move some terms so that I can find the y-intercept, which is b, okay, and the slope, which is m. That means I need y by itself. To get y by itself, I want to multiply this whole thing by 2. So I want to multiply each side of that equals by 2. Because if I multiply this side by 2, so to get rid of that denominator, I have to multiply this side by 2 to keep the equation balanced. So when I multiply this side by 2, I get y equals, great, that's what I want, distribute the 2 to each term, and I get 2x minus 6. I am now in slope-intercept form, which is exactly what I want. Okay, this is your m value. This is the slope, so the slope is 2. The y-intercept, your b value, is -6. Remember, your y-intercept is what y is. Y is -6 when x is 0. So this is the coordinate. This is the point that you want for your y-intercept, okay? X is 0, y is -6. So I would be plotting a point at -6 on my graph. Number 5. Find the x and y intercepts of this equation, x minus 3y equals -3. This equation is in standard form. To find the x-intercept, I'm finding what x equals when y is 0. Okay, so to find what x equals when y is 0, I'm going to substitute 0 in for y and find x. So I have x, this is anything times 0 is 0, right? So this is x equals -3, because this just is gone. So my x-intercept, x is -3 when y is 0. Okay, to find the y-intercept, this guy, the y-intercept is whatever y is when x is 0. So put 0 in for x, and then solve it for y. Okay, so 0 minus 3y, this is 0, this is nothing. The y is multiplied by -3, so I'm going to divide it by -3, both sides, and I end up with y equals 1. -3 divided by -3 is 1. So the y-intercept, okay, when x is 0, y is 1. When you go to graph this, and I know you've got a little graph there on your, let's see, I'll put this line right here, okay, and you've got a little graph there on your study guide. So when you go to graph this, you're going to plot these two intercepts, and then you're going to graph the line. So 0, 1, I'm going to put 1 right here, put a point right there. Okay, that's this one. 0, 1, and then -3, 1, 2, 3, 0. All right, so I'm going to call this one, this is -3. Obviously, this is 0, this is 0, 1. Here is your x-intercept, so this line is going to intercept the x-axis at -3. It's going to intercept the y-axis at 1. And then all I'm going to do now is graph my line. I don't have a ruler with me, guys, but that's the idea. Don't forget your arrows on either side to make sure that that is a line. All right, and that's the idea for number 5. Okay, let's move on to number 6. For number 6, you're interpreting a graph, okay? You're interpreting a graph, and I will show you what your graph looks like. You should be looking at it on your study guide so you can see what it looks like. But here's your graph. Your graph looks like this, and you've got 5 sections. A, from here to here is A, here to here is B, this is C, this is D, and this is E. You can see what this graph is measuring. It tells you here at the title, the temperature of water over time. Okay, so here's time. We're going to start at 0 minutes, and we can see here that from 0 minutes to 10 minutes, the water temperature, that's what's on this axis, is below 0. Think about that. What types of things could be below 0 on a graph? Temperature is one of those, right? Temperature of water, the air temperature can get below 0. So think about that, and when you're answering this problem, problem number 6 on your final. So if I'm going to interpret the A section right here, okay, I can see that from the time I start measuring to 10 minutes, so from 0 minutes to 10 minutes, the temperature is rising. It's coming from -20 degrees up to 0 degrees. From 10 minutes to 30 minutes, so over these 20 minutes, it's going to stay at freezing at 0 degrees. At 30 minutes, all the way up to 50 minutes, so for these 20 minutes, it makes a significant rise, right? So from 30 minutes to 50 minutes, it goes from 0 degrees to 100 degrees, this water. So I am thinking that we're boiling ice or something like that. that must be what's going on, and this water is increasing in time, in temperature, except that from 50 minutes to 80 minutes, so for this 30-minute stretch, it stays at 100 degrees. Then from 80 minutes to 90 minutes, these last 10 minutes, it makes a steep increase from 100 degrees to 160 degrees. So I don't know what's happening here with this water, what possible situation we have here, but here's how we would write the interpretations, okay? So that A section, the temperature, can you guys see that okay? Yeah. The temperature rises from below 0 degrees to 0 degrees over 10 minutes. That's what happens in that A section. In the B section, the temperature is constant, right at 0 degrees, right, for 20 minutes. In your C section, you have the temperature rising, so the temperature rises for 20 minutes. And remember, it rose from 0 to 100 degrees, so it made quite a jump. In your D section, let's see, is that what happened in C? Yeah, temperature rises, your temperature is rising for 20 minutes in C. I gotta look at it again. Okay. The D section, something weird happens. The temperature stays constant, so it's holding, right, at 100 degrees for 30 minutes. That's how long that segment was. And then the final segment, the temperature rises quickly in the last 10 minutes. I think it went from 100 degrees to 160 degrees. This is sufficient. All right, you guys, this is sufficient for an answer for number 6 in describing and evaluating, okay, interpreting what's happening on that graph. Okay, let's move on now to concepts that we covered in chapter 4, which is direct variation and inverse variation. Okay, so I wrote you some notes here for number 7. Remember that y varies directly with x. Remember what your equation for direct variation is. So you're given a direct variation here. They're telling you y varies directly with x, and they give you 2 values, okay? Y equals 18 when x equals 9. In the first box, I'm asking you, for letter A, to write the equation, okay? Write the equation for direct variation. Here's the equation for direct variation. Y equals kx, where k is the constant of variation. Okay, now, second, we're going to use our x and y values that we're given here, okay, to find k. That's what we're going to do for B. So for B, take y. Y is 18. I don't know what the constant of variation is yet. I'm going to solve for that right now. K times 9, because I know that y is 18 when x is 9. To find k, I'm going to divide both sides by 9, and I get 2 equals k. Now the whole point of this, the problem, okay, is to write a function rule. That's what we're going to do here now in letter C. Write a function rule for this situation, a direct variation when y equals 18 and x equals 9. In order to do that, we had to find k, because this is the equation that you're trying to fill in. Okay, you're trying to fill this in. When you rewrite your equation, leave x and y as variables and put your k value in right here so that your solution looks like this. Y equals 2, that's k, x. This is the function rule, so that for any value x and y, when you multiply x by 2, you're going to get y. Okay? This is the function rule for a direct variation when y equals 18 and x equals 9. Okay, we're going to try this now with inverse variation. So let's go on to problem 8. Hopefully this is making sense. Problem 8. Y varies inversely with x. Okay. Y is 12 when x is 6, and it's an inverse variation. So I want you to do the same thing. Letter A, write the equation for inverse variation. This is what it looks like. Y equals k over x. That's your equation for inverse variation. You could write it xy equals k and still get the right answer, but because we're driving toward writing a function rule, which begins with y equals, I'm going to write my equation in the form y equals. Okay? Okay, for letter B, put your values in for x and y and find k. Okay? So y equals 12, k over x is 6. To solve for k, I need to multiply both sides of this equation by 6. Whatever I multiply this side by, I have to multiply this side by to maintain my equality. Okay, so here we go. That gets rid of this guy. 6 times 12 is 72 equals k. Brilliant. Okay, now, letter C. We're writing a function rule. So I want to go back to this equation here. Leave x and y as variables. Y equals, and put your k value in. 72 over x. You've now found the function rule for this relationship, okay? When an inverse relationship between y and x can be represented here if you know these values, that when you take 72 and divide it by x, you're going to get y. And that's going to happen for all values x and y that are inversely, that vary inversely when y is 12 and x is 6. Right. Let's go on to number 9. A couple more problems and we're done, guys, with this section. Okay, for this one, you're going to use the table to find the function rule. I'm going to redraw it real quick so that you can see. Okay, so I have x and y here, and the values that I had is that when x is 3, negative 3, y is negative 4. When x is negative 1, y is negative 2. When x is 0, y is negative 1. I need 2 more. When x is 1, y is 0. And when x is 3, y is 2. So I'm looking at this, and I'm supposed to write a function rule, meaning what happens, okay, what is going on, what kind of change in x do I have that's producing these y values? So let's look at the relationship here between these two first. So here I could write y is this one, right, is 1 less than whatever x is. So x here is negative 3, y is negative 4. So y is x minus 1, right? Negative 4 is this y value minus 1. Now, does that hold for the rest of them? Can you make that same evaluation? Is negative 2 1 less than negative 1? Yes. Is negative 1 1 less than 0? Yes. Is 0 1 less than 1? Yes. Is 2 1 less than 3? Yes. So that's your function rule. You're looking at the relationship here, okay? So when x changes, what happens to y? That's what we're looking at here. So y is always going to be 1 less than x. All right? That's what I'm looking at there. That's what I'm evaluating. Okay, we've got one more problem to solve. This problem was from chapter 5. All right, guys, so we're switching gears just a little bit. You've got a word problem. When a new car is purchased, it immediately begins to lose value or depreciate. That's what depreciate means. Depreciate means to lose value. All right? The car started at $28,550. That's what it was worth when the person bought it. Now, over 7 years, okay, so over a 7-year process, it's going to lose money every year. And after 7 years, that car is now going to be worth $13,500. So the question that they're asking us here is to find, to write a function rule to find the value of the car over time. The first thing we need to do is we need to figure out how much money is this car losing every year? How much value is the car losing every year? Well, okay, first thing we got to do is figure out how much did it lose over 7 years. So it started at $28,550. If I subtract 13,500, that will tell me how much it lost total over those 7 years. Right? So I end up here with $15,050 is what it lost over the full 7 years. Okay? The rate of change then, to find the rate of change, I'm going to take 15,050 and divide it by 7, and that'll tell me how many dollars, okay, it lost, how much value it lost each year. So if it lost this in 7 years, then when I divide them, I'll find out how much it lost in 1 year. When I take 15,050 and I divide it by 7, I'm going to find out that it lost, if it lost the same amount every year, that's what we're assuming, okay, then it depreciated, it lost a value of $2,150 every single year. Now, to write a function rule for this, the value of the car over time, so I'm writing the value of the car as a function of time, it's losing this amount every year, right? So this, if I were going to represent this on a graph, okay, this is the slope. This is the rate of change. It's losing minus $2,150 every single year, every time period. Okay, it loses that. Now it started at $28,550. So I put that here at the end of my function because this is the point where this graph would cross the y-axis, right? So let's just say that I had drawn a straight line here. And you were going to say, what's the value of the car over time? Well, it's going to start at $28,550 and it's going to lose, okay, over 7 years. 1, 2, 3, 4, 5, 6, 7. At this point, it's going to be, well, let's call this point here. I don't know. I'm just guessing, you guys. Let me put it here. Let's call this your 13.5. Okay, at 7 years, it's going to have gone down, right? Like this, but it started here at this point. So you can see that this is the graph of a line, right? This tells me this is where it started. That's my y-intercept. That's my b value. It starts at 28,550 and it goes down. That's why I have a negative slope, 2,150 every year over 7 years until at year 7, it's $13,500. So this is the function rule. The value of this car over time is negative 2,150 times time, which we're going to say is a year, and it starts at 28,550. That's what you need to know to be able to solve problem 10 on this part of your final.